near-miss asteroids, flying by Earth and going unnoticed by NASA until they're too close for comfort, appear frequently. But they're a source of dismay for the scientists tasked with studying asteroids. Sensational articles about asteroids like 2019 OK, 2020 LD, and 2020 QG feature descriptions such as car-sized, bus-sized, and city-killing. Such stories often emphasize that they were unseen until passing very close to the planet. But though it might not be what people want from the world's foremost space agency, NASA isn't tracking every single asteroid in the solar system. It isn't even trying to. NASA is closely tracking NEOs, or near-Earth objects, only after they exceed a certain size. This size is around 460 feet in diameter, which is bigger than any car or bus. In fact, it's about a third of the height of the Empire State Building. So these smaller asteroids, despite being used in scaremongering news stories, aren't of any concern to NASA and would likely cause very little damage if they were to strike Earth. The good news is that the bigger an asteroid is, the easier it is for NASA to track. And NASA does have a goal of detecting and tracking 90% of NEOs above 460 feet in size, charting their trajectory and deciding how dangerous they actually are. Suffice it to say, NASA would certainly spot a planet-destroying asteroid like the one that killed the dinosaurs. You wouldn't even need a telescope to see a 10-mile-wide asteroid approaching the planet. While cataloging 100% of NEOs out there would be nice, it's just not feasible. And asteroids this big can't simply appear out of nowhere. The asteroids in the solar system are caught in a heliocentric orbit, just like the Earth. Technically, they're categorized as minor planets. Most reside in the asteroid belt between the orbits of Mars and Jupiter. Once a minor planet exceeds a certain size, it's classified as a dwarf planet. We have 5 named dwarf planets in the solar system at the moment. Pluto is the most famous, but there's also Eris, Ceres, Makemake, and Haumea. While Ceres occupies the asteroid belt, the others are trans-Neptunian objects located all the way out in the Kuiper belt. We know what these objects are, we know where they are, and we know it's highly unlikely they'll leave their orbits and embark on a crash course towards planet Earth. If, or rather when they do, we'll have a lot of warning and a lot of time to predict where they're going to go. Bearing in mind that while the Earth's gravity can attract asteroids, there's still a lot of empty space to get through to reach us, which also reduces the chance of a devastating impact event. Unfortunately though, even if there is a dangerous asteroid heading towards us and NASA knows about it years ahead of time, we don't actually have many resources to avoid it. In the near future, NASA will launch the DART spacecraft, which stands for Double Asteroid Redirection Test. DART aims to reach the asteroid Didymos in 2022. It will study Didymos and its moonlet Dimorphos, and then crash itself into Dimorphos at a speed of 14,800 miles per hour. NASA will then observe Dimorphos and see if we've been able to alter its orbit at all. It's a low-risk experiment because Dimorphos isn't going to crash into Earth, but it will prove whether or not we can change the trajectories of incoming asteroids by just crashing big enough objects into them. If DART doesn't work, we could try building a bigger spacecraft to crash into an asteroid. An alternative, however, would be to just use nuclear weapons. Contrary to popular belief, this method wouldn't necessarily aim to destroy the asteroid with nukes, which could just break the asteroid into smaller pieces. The asteroid might then reassemble thanks to gravity. Instead, scientists would launch a craft armed with a nuclear bomb that would detonate close to the asteroid in the hope that the force of the explosion would change its course. But this has problems as well, namely that it's untested and that placing or using WMDs in space is forbidden by international law. Now, maybe international law would be ignored if nukes in space were our last line of defense against doomsday. But we should certainly look at other ideas before resorting to nuclear weapons, especially if having different options ready could make the difference between extinction and survival. To this end, scientists are also investigating whether lasers could deflect and destroy asteroids. One laser-based initiative is the Directed Energy System for Targeting of Asteroids and Exploration, or D-STAR. Essentially, D-STAR is an enormous satellite that could generate a big enough laser to vaporize incoming objects. However, again, D-STAR could easily pose a huge danger to Earth depending on who was controlling it. In the 1980s, Ronald Reagan's plan to build an orbital defense system that could destroy incoming nuclear warheads became a huge obstacle to ending the Cold War. It's easy to imagine worldwide objections to any country placing a giant laser weapon into orbit, even if it was for asteroid defense. Finally, there's the idea of using a gravity tractor. Sadly, this would not involve a giant tractor beam, which for now remains in the domain of science fiction. Real-world experiments to build tractor beams have only succeeded at the microscopic level. Instead, this solution to the asteroid problem would involve the construction of a massive spaceship which would fly alongside the asteroid and use gravity to shift its course. However, the spaceship's mass would have to be considerable, and it would need to accompany the asteroid for years. There's no guarantee that we'd have the time to build such a spaceship or to sit back while it slowly tugged the asteroid out of our path. These ambitious initiatives might be exciting, but if we're faced with the tangible threat of an incoming impact, we don't currently have the requisite tools at our disposal. This means that we might have to treat an asteroid impact like any other natural disaster we can't influence, such as earthquakes and tsunamis, and try to provide disaster relief. Two of the most prominent asteroid impacts in the last century, 1908's Tunguska event and the Chelyabinsk meteor in 2013, exploded over land, causing far-reaching destruction. The Tunguska meteor is estimated to have been up to 650 feet in diameter, and the Chelyabinsk meteor about 66 feet. In both cases, we were lucky enough that no deaths were confirmed. So the human race has survived asteroids before. The question is, how would we best prepare? 71% of Earth's surface area is water, which means that if an asteroid does strike, it's statistically more likely to land in the ocean. A big enough asteroid could easily produce a tsunami the same way that the force of underwater earthquakes can cause them. But though we know how to prepare for tsunamis, and many countries have tsunami warning systems and disaster relief plans, an asteroid could hit anywhere in the sea, whereas tsunamis almost always start along plate boundaries. This means that it would be incredibly difficult to prepare for. The size of such a tsunami might also be completely overwhelming, literally miles high. Faced with such a mega tsunami, there's little we could do except run for the hills well in advance. It would be worse, however, if the asteroid hit land. The Chicxulub impact that killed the dinosaurs exploded in a 100 million megaton blast, destroying all life for hundreds of miles with supersonic winds. Fire rained from the sky around the globe and dust darkened the sun, plunging the world into darkness and scouring much of the planet of life. Plant life could die off within weeks. To survive such a catastrophe, we would need underground bunkers stocked with food. And even then, life would be a struggle for a long time to come. Fortunately, collisions this large are thought to threaten the planet only once every 20 million years or so. So the odds of one occurring within our lifetimes is extremely minute. NASA misses asteroids because the asteroids that become notorious news stories aren't actually all that dangerous and would do minimal damage if they did beat the odds and crash into Earth. And that's why NASA keeps missing asteroids.